Okay, now in this segment, I want to go over one of the best kept secrets about the MCAT with you. Now, I'm sure that in your physics class, you got in the habit of solving lots of problems in terms of forces, velocities, accelerations, and all that stuff, right? Well, I'm going to teach you today to try to break that habit and try to start to solve problems in terms of conservation of energy first. Now, the reason why conservation of energy is a better method to first attempt a problem is because, number one, it's going to get you to the right answer a lot faster if it works. And when it doesn't work, and it doesn't some of the time, you're going to be able to recognize that it doesn't work a lot faster than you would if you had solved in terms of forces first. Because there are also occasions when solving problems in terms of forces is not going to work out. There might not be enough information in the passage to solve in terms of that. So you might have to solve in terms of conservation of energy. But the problem with using forces is that it takes a really long time to figure out that you've gone too far down and that there is no end in sight. And at that point, then you have to turn around and remember that you can solve it in terms of conservation energy. By then, you've already wasted too much time and it's probably too late and time to move on. So always try conservation energy first. And as you get better and faster, you will very quickly recognize what types of problems you're going to need to use conservation of energy for and what types of problems you're going to need to use forces for. But for now, when you're just starting, always try conservation energy first. If it doesn't work, then go on to forces. And now let me illustrate why. So the main reason why is because energy is a path-independent process. Let me give you an example. Let's say that we've got an object that we want to lift up to this height. It doesn't matter if we lift it up this way or if we lift it up this way. It will take the exact same amount of energy in both cases to get it up to this height. Now the forces will be reduced, and you'll understand that a little bit more after you watch the video about work. But for right now, just focus on the idea that energy is conserved. We cannot create nor destroy energy. And what that tells us is that it takes the exact same amount of energy to get from point A to point B, regardless of how we got there. We could get there from any number of angles. And it might take different forces, it might require longer distances, but it will take the exact same amount of energy to get from the beginning to the end. And that's really all you need to focus on for conservation energy problems. You get to ignore all the stuff in the middle and focus just on what you have at the beginning and what you have at the end. So let's say that in this case, I asked you to solve for the force required to lift this object up this plane. There are two ways to solve it from here. You could choose to go the forces route, or you could choose to go the energy route. So let me go ahead and show you how you would have to do it the forces route first. In order to do the forces route, you would first have to, imagine your object on the plane. Think about how it really is experiencing a gravitational force of mg. And then you're going to have to say, okay, well, that mg force is not able to be perfectly exerted on the object because of this normal force pressing on it. The normal force is perpendicular to my object on the plane. Because of that, that's going to decrease the amount of force required to lift my block up this ramp. And that amount of force would be the force parallel to the ramp. So I get that side of my triangle. And then I say, well, okay, whatever that angle is there, that angle is going to be equal to this angle right here. And you have to be very careful about that to know that it's this angle and not this angle. And you have to know that this angle is a 90-degree angle. So already we're just getting into a lot of detail and we're not even there yet, right? So now we got to use trigonometry to say, okay, well, if I want the force going up the plane, then I want that parallel force. So if I want that parallel force, then that is going to be the opposite side to the hypotenuse. So you're going to use sine theta, whatever this theta was, times mg to get the value of the force required to lift it up the plane. So we finally got our answer, right? But it took us a long time. There were a lot of things we needed to think about in order to get there. It just goes to show that forces work and you can get there and still fairly quickly. But I'm going to show you how conservation of energy would be an even better way to solve this problem. Because it takes the exact same amount of energy in both cases, I'm just going to calculate the amount of energy it took. So that's my change in energy. So I started out with 0 potential energy. I end up with some amount of potential energy, which I can find by mgh. So mgh minus 0 leaves me with mgh. Now notice that that's my force right there, right? But that's the force going straight up this height, right? So if I want the true force going up here, I need to find out how much work it would take to get me up here, right? And remember that it's going to take the exact same amount of work both times. And this is our equation for work, which you'll learn in a lesson very soon. So it's going to go a certain force over a greater distance, so then all you do is take that distance, divide by that, and there's your force. So notice how much easier that is. It's so fast, it's so simple. You're focusing on the idea that energy is always conserved. You're able to ignore the angles and all the tricky things. You don't have to remember that that angle is equal to that angle anymore. And then on top of all that, if they didn't give you one of these distances, you would still be totally fine, because you would write down this equation and very quickly recognize, oh, I don't have a distance. I can't solve it this way, so I guess I'd better go the forces route. But on the other hand, let's say that you decided to go the forces route. Well, if they didn't give you the angle of the incline, it's going to take you a while to get to this point in your solution to figure out that, shoot, I don't know that angle, so I don't know my sine, so I can't find the value of my force, right? So that's what you have to be really careful about, is the forces route is a lot longer, it's a lot harder generally. And so for that reason, if you choose to go that way first, and you could have solved it in terms of conservation of energy, then you will have wasted a lot of time. Not only that, but if you can't solve it in terms of forces, then you're kind of stuck. And it's kind of a win-win situation, because if you start with conservation energy, it will take you less time to figure out you've made a mistake and gone the wrong route, and it will take you a lot less time to solve the problem if it does work out. So give it a shot on a few problems. See how it works for you. Now, regardless of whether you choose to take my advice or not, just remember that conservation of energy is a huge deal on the MCAT. They love to test on this, and there are quite a few problems that you will see that you actually can't solve in terms of forces. You have to use conservation of energy. So what I'm going to do is I'm going to give you a few practice problems here, and I'm going to let you give it a shot. And again, you can choose whichever way you want, but I would highly suggest attempting solving these problems in terms of conservation of energy first, seeing how it works for you. And over time, you can continue to practice this until the point where you are very comfortable solving problems using that strategy. So in this case, let's say that this is you on top of this cliff. Let's say that you have a mass of 60 kilograms. And let's say that with your mass of 60 kilograms that you jump off the top of this cliff, which we'll say is 50 meters high. You jump from a height of 50 meters into the water below, and let's say that it takes you 10 meters before you stop moving and can start to swim back to the top. If that's the case, what is the value of the buoyancy force the water is exerting on you? Well, this problem is actually impossible to solve using just forces. You have to solve it in terms of conservation energy. So I'm just going to show you that method, because obviously it's the only one that'll work. Initially, we start off with some potential energy, right? So mgh is our initial. Now obviously that energy is going to be converted to kinetic energy as we fall, and then as we hit the water, all of our kinetic energy is going to go into the energy of displacing the water, which is why we're going to get a buoyancy force acting on us, which is why we're eventually going to slow down. So this water is going to do work on us because of that force that's acting on us over a certain distance. So again, we can totally ignore the stuff in the middle about kinetic energy. It doesn't matter that we produce kinetic energy at some point. We just care about the initial and final. And at the end is where our work was done. Because we see that we start with some amount of potential energy, and at the end we start with 0 potential energy and 0 kinetic energy when we finally come to a stop 10 meters underneath the water, right? So we set mgh, our potential energy, equal to our work, which again is force times the distance. So mgh in this case is going to be 60 times 10 times 50, and that's all going to be equal to force times a distance. Okay, so you notice that our distance cancels out that 10 over there, so we got 60 times 50, which is going to leave us with 3,000. And there you go, there's your answer. So 3,000 newtons is the buoyancy force acting on us. And that's how simple it is. I'm sure that this was a difficult problem for you to attempt, but you can see that it's a very easy problem to solve. Keep your mind focused on conservation of energy. Always attempt it first, and again, if it doesn't work, it's okay. You're going to figure out that it doesn't work very early on, and you'll be fine doing the forces method.